business today. So if you guys remember, so far we're still working on photogrammetry chapter. So in the last lecture, what I did is I gave you a quick demo on a software called Zephyr. And what it does, it takes your two-dimensional photos that they maintain some sort of overlap, and then it does all the magic, it finds all the matching, it does all the calculation on your behalf, and the final outcome is a 3D model textured with the color information. So this is something we've done in the last class. Also, in the last class, we start looking at drones. And as I said, drones for us, some people, they use it for fun. But for us in photogrammetry, we use it as a platform, a cheap platform that can take our sensor, which is the camera, flight above one area, and we are able to take those photos and simply create a 3D model for mapping purposes. We looked at few designs. We looked at quadcopter and multicopters, and we looked at fixed wings, and we also finally looked at something called the VTOL. And every one of those, they vary in price, they vary in lifetime, like battery lifetime, and they vary in terms of application. So that was covered in the last class. Today, we have a very interesting session that has lots of videos. So I handpicked some videos from YouTube that's showing you different aspects of drones. So my first video today is a video about the whole workflow of photogrammetry, starting from the planning, going to the flight, and then finally the processing. And so really in each video that I will show you today, I will show you the video, and what happens next is I will give you comments on the video. Something before I start, I'm not sure if you already noticed that the nature of the course is changing. The first part of the course is about calculation, whether total station or maybe volume calculation. But this part of the course is very theoretical. And what does it mean? It means we have no calculations. And I'm pretty sure that some of you are questioning how my final exam will be, how the assignment would be. So there will be an assignment, which is not really, there is not a single calculation in photogrammetry assignment. It's all about true and false and MCQ. So you will see this coming very soon. So this will give you an idea of how the final exam will look like. So there is no calculation. It's all about true and false and also about MCQ. Uh, it's kind of a challenging for some of you. If you enjoy the material, it comes very natural. Huh? If you enjoy the material, enjoy the discussion, all what I'm saying kind of sticks in your mind. I can see from the attendance, some of you are very interested. I can see them every single class, and some others, they probably never show in my class. I'm not sure if they are watching the videos, but again, I'm saying if you naturally love what I'm saying, then the final exam will be super easy for you because simply you kind of always remember what I'm saying. But some others, you know what, it will be not as easy. Okay, so let's get started. And as I said, we will show you some videos, very entertaining, and then we'll give you very, very important comments. Let's go ahead and watch the video. So you can see here in my slides, I give you the video itself, and also I place here the link because as I'm printing a PDF, you will not be able to click here, right? So because that's only on PowerPoint. And below here, I also give you a link where this link will be live link on PDF. So if you want to watch these videos after the fact, then you're welcome to click on this link here, which will open for you the video.
When advertising on YouTube, I know that making an authentic video with a clear call to action is the key to getting results.
To get started, download the Pix4D app on your mobile device. Select Grid Mission since it is the easiest to use and in my experience produces the best results. As you can see, you can adjust all the parameters of the area that you're going to be mapping. The application will warn you if the area is too large to be flown. If you click on the battery symbol on the right hand side, a lot of vital information will be displayed. You can also adjust the altitude in meters. The higher, the less time it will take, but also the lower the resolution will be. I use 50 meters as that gives a good balance. There is also a camera mode, but I do not use it since it does not help me. Here are some settings that can be left alone. You can also reset the area to its default size. The predicted time to complete the flight is displayed in the lower left-hand corner. Once familiarized with the application, connect your device to the controller and fully charge the battery. It is also recommended that you update the software on the Phantom and on the remote controller. Place the Phantom in an open area that is clear of trees and other obstacles. The application will only work when the flight mode switch is in the F position, the leftmost one. If at any point you need to regain manual control, move the switch to the A position. Once you are happy with the shape and size of the area you are mapping, press start, read the instructions and press takeoff. The Phantom will now automatically take off and ascend to the indicated altitude. It will then fly towards the start point. Once there, it will fly to the next waypoint, stop, take a picture and repeat the process. Of course, be ready to set the switch to the A position if a problem arises. The Phantom will stay on course even if there's relatively strong wind. Once the mission is finished, the Phantom will return to the home point. I would advise landing the Phantom manually so you can land it in the correct place. Once landed, import all the images taken and download the trial version or buy Pix4D. Open Pix4D and select New Project. Name it and select where you want it to be stored. Now, import your images. As you can see, the images have been geolocated correctly. On the bottom are processing options. If the second step in processing does not work, try changing the quality or the output options. Click Start and the processing will begin. This process might take a very long time. It is recommended to have a powerful computer with a lot of RAM as it will dictate how many images you can process. I have 8 GB and my limit is roughly 100 images. Once the processing is finished, it will look something like this. To see the final result, turn off cameras and enable the mesh option. It will now load the mesh. The quality of the mesh may depend on the time of day, the altitude, and your quality settings.
So that was my first video here, and I will go back to my presentation. Really, what I want to emphasize for you guys here is that when you try to use drones to perform a photogrammetry mission and create a map for certain area, you simply have to go through three different steps. Remember, three different kind of stages. And hopefully you guys capture this from the video. A stage before you go to the site, completely in the office, where you will do some sort of planning, create a mission, and I will give you a demo. Although I know that there was a little demo on this app on the video, but I will give you a full demo on the app. I'm not sure if it's today or some other time next class, but I will give you a demo on this app. So in the app, you have to, for example, tell the software what is your area of interest that you want to scan and set some other parameters. So this is stage number one. It's called flight planning. Then from flight planning, you go to the actual site and simply the application on your cell phone or tablet will completely control your drone. Okay, because simply the app will do some design on your behalf. As I said, just wait until I give you the demo and I will tell you what this means. So, but the drone is completely under the control of the app. Okay, so the app will fly the drone, send the drone to the right elevation, go along some flight lines, take some photos at pre-designed photo location, and then once the mission is finished, the drone will automatically come back to where it flew from. And then what you do is you go to your next stage, which is the data processing. So data processing, you'll take the image. And I know that if you watch my demo from last class, which we used Zapier, right? And then this video here is talking about other software which is not free. It's called Bix 4D. Bix 4D. And although they are two different software, however, if you watch my video of last class and this time, you will see there is 100% similar. You are very, very, very similar. And what does it mean? It means, look at this. We have to load the photos. We have to set some parameters and let the software run for 1 hour, 2 hours, 1 day or 2 days until you get your final product, which is a full textured 3D model of your area. I need some confirmation. Did you guys get the same feeling that Dex 4D, although it's a different software, it works the same way as Zapier?
Yes, but it seems faster.
It's, those videos are cut, so they are cut, so they don't show you the how many hours did it work. They edit the video, and so they click on start, and then let's say it took 2 hours. They record another part of the video, stitch them together. So you don't see really how long did it take to create the model. Okay, I can tell you, none of the software will do in the video like 1 second you get your model. It will take, as I said, hours, sometimes even days. I will share with you one of my friends' experience who work in drone. It took him 3 days on a very, very powerful laptop, like a kind of customized laptop. 3 days. Can you imagine? 72 hours. The software is working to get you your 3D model. The reason is we have so many photos, maybe sometimes over 20,000 photos. Okay. Anyway, at this point of time, really what I wanted to show you is that any mission, it includes three stages. A stage that happens in the office, kind of planning for your mission, and then an actual mission that you take the photos, and then finally a third mission, a third stage where you process the data and create your model. Okay, let's move on to the next step or the next video, which is about another kind of drone. I think I showed you this drone in my presentation. What do we call these drones? We call them fixed wings, fixed wing drone. So I'll show you the video one more time, and then we have a little discussion. Let's go ahead and watch the video.
Imagine being able to achieve highly accurate mapping whenever and wherever needed, even in less than favorable weather conditions, such as wind, light rain and cloud cover, where conventional photogrammetry simply won't suffice, while staying with both feet firmly on the ground. Introducing the Gatewing X100, revolutionary aerial mapping and surveying system. The Gatewing X100 is a game changer because this system is revolutionizing the surveying and mapping industry like never before. The gap between traditional terrestrial surveying and conventional photogrammetry has finally been filled. Now, surveyors can remotely and safely measure large, difficult to reach or dangerous areas. For photogrammetrists, smaller projects suddenly become highly cost-effective. The Gatewing concept consists of two main elements: image acquisition and image processing. Image acquisition is conducted using the X100, a light, unmanned aircraft with an onboard, high-quality calibrated camera which captures images with a resolution of 5 centimeters when flying at a default altitude of 150 meters. The image resolution can be altered by modifying the flying altitude. The strength of the system lies in the fact that flights are conducted in a fully automated manner, from launch to landing. No piloting skills are required to fly the X100. Instead, you merely facilitate the aircraft's operation, which includes indicating the area to be covered and selecting a takeoff and landing spot. Simply plan the area that needs to be scanned based on the easy-to-use software wizard. Launch the device and let the X100 cover the predefined area. Through parallel sweeps following a regular shape, the aircraft will then take high-quality pictures with a high overlap. The ground control station is only used to monitor the flight and to allow an on-site image quality check. The patent-pending sturdy body, made from expanded polypropylene and reinforced with a carbon frame, was custom designed by Gatewing engineers for its durability, power efficiency, and outstanding weatherproof properties. Because of the lightweight material and built-in fail-safe procedures, the X100 is the safest unmanned aircraft ever made. The X100 was designed for maximum coverage. With one single battery charge, the aircraft can scan several square kilometers. Another key factor in the design of the X100 was its employability in different weather conditions. The device operates perfectly in hot, cold, drizzly, and windy conditions, with wind speeds of up to 60 kilometers an hour. The X100 packs some amazing technology into a 2-kilogram platform with a wingspan of only 100 centimeters. This makes it easy to carry and use anywhere. All these features make the Gatewing X100 the world's fastest and easiest to use professional surveying and mapping tool. For the creation of orthophotos or digital surface models, Gatewing offers StretchOut, a highly automated software package that converts your raw X100 image dataset in no time with just a couple of clicks. If you do not wish to invest in standalone software, you can simply upload your images to the Gatewing cloud, and just a few hours later, you'll receive your orthophoto or DSM. With both software solutions, the quality of the results is outstanding, razor sharp, no artifacts, intense colors, and above all, the spatial accuracy which makes it a true surveying tool.
Hey, I'm back. I think there are so many, oh my God, there are so many things I can talk about it in this video, okay? So I'm just asking you one question. So you can see this is a different design from quadcopter, but I'm asking you in terms of the process, do you see any difference between the process of using a fixed wing or quadcopter, or they follow the same process, like I mean 3 stages? What do you think?
Pretty much the same.
Yeah, pretty much the same. So you can see there is a it's just different names, huh? So they have their own different app, which they have to pick the area and set where the drone will fly from, and then simply the app will take over, will control the drone, until it covers the entire area. When it comes back, you just do the processing after you download all the photos. So this is one discussion I wanted to make sure that you guys understand that although we have different kind of design of drones, but the process is still the same. So that's one thing. The other thing, if you notice how this drone will fly, did you guys see what happens? They put it on a kind of I don't know what to call it, like a bridge or something that simply you stretch it and it simply give a big push for the drone to put it in the right elevation. And if you see the drone can cover few kilometers with a single battery charge. And I think we already discussed this. We said like the fixed wing drones, because of their design, they fly based on the aerodynamics around the wings. And that's why they don't consume that much energy, and that's why they can cover larger area. So that's one thing also I want everyone to understand. One more thing is that when it comes to processing, you can, when you download the images, you can buy their software, which is called Stretch Out. So Stretch Out will do exactly the same thing as Zapier or maybe Pix4D. All of them, what they do is you give them the image, they can simply give you your digital surface model or your 3D model in a color you can see. Now, other option is, because it's kind of, there is another business model. It's completely from economical perspective. Those software, they are expensive, okay, to buy. And so every company is trying to offer their client a different option. So what's the other option? Instead of you buying the software license, then instead you do the computation in the cloud. So you don't buy the software, rather than uploading your photos to the cloud. The software is available on the server. They process the data, and you only get back your 3D model or orthophoto. Okay, so that's a different model. And why they do that is because couple of things. Number one, they want to protect their license. You guys know that there are lots of piracy and break of their software. So if they maintain their software on the cloud, it means there is a protection of their software. The other thing is, processing in the cloud is way cheaper than when you buy the license. So if you have one client or one company that's not really doing photogrammetry every day, let's say they do a photogrammetry project every 6 months, which means they use the software twice per year. Do you think, does it make sense to buy the license or just process on demand or pay on demand? I'm thinking that paying on demand is more cost effective. Okay. One more thing I need to remind you, having a drone, it simply fills the gap in between conventional survey, like total elevation and GPS, against conventional aerial photogrammetry, where you need a big aircraft and you hire a pilot, stuff like that. So right now, you can use photogrammetry in a small scale, even flying a drone above a house and creating a 3D model for a single house, which is something that was not available 20 years ago, okay? Now, finally, really the last comment is that when you look at the product, watch this product, okay? Few things you will notice here. How about the quality? This is called an orthophoto or a digital surface model. So the quality is super high. You have millions and millions of points, so the density of the point is super high. You don't get those discrete points using total station or GPS. So that's something you need to consider. Also, your product comes with a color. You guys understand that, huh? In total station or GPS, you get only XYZ, while photogrammetry, you also get color information, which is a plus, it's an advantage. Okay, finally, here is my final comment. I'm asking you, on this application here, which is a mine. So what you see on my screen is a mine. What do you think? Is that something that it's easy to be surveying using total station or GPS? And what's the problem there if you're doing a survey using traditional technique with total station or GPS in a mine? What's the problem there?
There's a lot of different spots you have to move to, different elevations.
For sure, that's one thing. And you can see we are getting on a slope, and I'm asking you those slopes, to move on these slopes. Is that safe or unsafe?
Probably
Unsafe.
unsafe.
Completely unsafe. And remember, there are some machinery like dozers are working their way, and this is completely unsafe process using GPS or total station where you have to be physically on the point. While using photogrammetry, it simply saves you all and make the process entirely safe. I'm hoping that you guys understand that. Okay, now, so I think let's see where are we at right now, and then probably I can. Okay, so I'm gonna talk about this slide, then we can go for a demo on Bix4D app. Okay, so this slide here.
Tahir, can I ask a quick question?
Oh, sure, go ahead.
Just what does it look like when you're doing that stuff and you have like moving targets below? Like if cars are moving or if the wind's blowing trees, does that mess up the photogrammetry accuracy or?
That's an amazing question. Amazing. Okay, thank you so much. So as I said, if you remember when I discussed with you photogrammetry, I said that you either move the camera or move the object. Anybody remember this statement? Move the camera or move the object, correct? But you cannot move both of them on the same time. So either you have a still object and you move the camera around like what I did with the mask, or the other option is keep your camera fixed and put your object on a turning table, so the table will turn, and then you can take photo from any direction you like, right? So those are your options. However, in photogrammetry, it's forbidden that you move both of them. And so here we go. There are some stuff like exactly what Ryan said. What if I'm flying my drone and there is a dozer is moving, okay? And I'm not stopping the process, okay? So there are some tricks that to go for sure. If you just process normally, what happens is you will get your digital surface model, you will get some sort of noise. It will simply mess up your model only where this moving object is moving, because simply when you do the matching, it doesn't really match the exact point. So the light rays will simply intersect somewhere else, maybe way lower than it should be, or maybe way higher than it should be. You understand?
Yes, that makes sense.
Okay, so what happens here, there is some tricks in processing that you can do. So in our processing, we can do several levels of resolution. We can do low resolution or high resolution. If we know that there are some blowing wind that moves the trees, or maybe there are some moving object, we can do the processing on a lower level. So what does it mean lower level? It means we take less point, and this simply eliminate those kind of noise. It's on the processing. We don't have to stop the process. We don't have to. We cannot do that. Huh? We cannot say wind stop. We need to do photogrammetry. We cannot do that. And hopefully this answer makes sense for you. Just about processing. Now I have Kitan.
Hello.
Go ahead.
Yeah. Can we get elevation points of surface from this drone? Or we can get pictures? Okay.
Absolutely, it's not. So you have two products. You can get digital surface model. When I say digital surface model, it's 3D, same as the face. Do you see the face, like the mask that I processed last class? So you can get full 3D model, or you can get an orthophoto. An orthophoto, it just rectifies your image, which means remove all relief displacement. An orthophoto is a two-dimensional product, which means showing you the right location of the object. So you can get both products, an orthophoto, no elevation, or you can get a full textured 3D model. Any other questions? I like this discussion because it looks like you guys are following what I'm trying to say or deliver to you. Okay, next is, as I said, this slide is a very important slide because it kind of summarizes for you the 3 stages that you have seen in the last video. Namely, number 1 is a flight planning stage, which happens completely before you take your drone to the site, including the right drone. So you have to plan. I need some drone. Should I buy or use the DJI Phantom 4, or should I buy Bix4D? It depends on the nature of the project, okay, and the size of your project. If you have a linear project, when I say linear project, I'm referring to like electrical cables, like a power cable, roads. Those are linear projects. They extend for how many kilometers, and the width of your project is kind of tiny, huh? Maybe 40, 50, 100 meter wide. You know what? In this case, the fixed wing drone, it really works very well because it can fly for longer distance, but you know what? It doesn't rotate as easy. Think about it, how easy the fixed wing drone can take a turn and go back to a barrel line. It has to go on a radius because you cannot stop it. While quadcopter, it stops in the air and then you can turn 90 degrees and you can come back along the next line. Okay, so it depends on your application. You must pick the right drone. Number two, pick the right application. Pick the right application. Tahir, what do you mean by right application? For example, Bix 4D Capture, which I will give you a full demo in a minute. Bix 4D Capture is an app, not a software. It's an app that controls the drone and to take the good photos. How many of those apps do we have? Oh my God. We have so many apps available to control your drone. There is a drone deploy, there is Bix 4D app. There are so many of them. And those, some of them, they are free. So for example, Bix 4D Capture, it's free. You don't have to pay a single penny for Bix 4D Capture, while drone deploy is you have to pay probably $30 or $35 for it. Why we have different application? Because every application, it has different design and it matches one application. For example, if you want to fly your drone for a high-rise building, you want to make a 3D model for a high-rise building. So it looks like the drone will have to go in a spiral. I'm not sure if you guys can visualize that, huh? If you want to survey a high-rise building, so your drone will have to fly around your high-rise building in a spiral pattern. So it goes kind of a circular, but it elevates itself up as it goes. Okay, so this pattern, it is not available in Bix 4D Capture. Okay, so hopefully you get this the point here. It depends on your application or what you're trying to do. You need to pick the right application. Number three on my list here, understand the site. And what does it mean, understand the site? This is kind of a vague word. What does it mean, understand the site? I'm going to explain. Understanding the site, it means you have to visit the site without any drone. Just you. Look at the site. Do I have trees? Maybe yes, maybe no. Do I have a power cable? Maybe yes, maybe no. What is the average height of the building in this area? For example, look at SAIT. You guys remember SAIT, or you totally forget about SAIT? Anybody remember how SAIT looks like, the height of the building? So in SAIT, most of the building, they are short. Maybe they are 4 or 5 floors, while there is one building in SAIT that stands up for about, I think, 11 or 12 floors. Okay? Anybody can confirm that you guys still remember SAIT? I myself probably almost forget. Okay, so anyway, so why we're asking about to find the height of the building? Because remember, what if I fly my drone on a height that's very close to the building height? Am I safe or unsafe? Guys, I need you guys to give me some input because I feel lonely. I'm asking you if my height, let's say the building heights at SAIT, one of them sticks at, let's say, 40 meter and other building at, let's say, 20 meter. Okay, I'm asking you, can I fly my drone at height of 30 meter above ground?
No, probably not.
You will hit the building. Okay, so that's why you need to get a knowledge of the site itself. Do we have trees? Because trees, okay, trees are maybe we may hit the trees with our drones, and you have to be mindful of the structure of your site. That's why visit the site, understand, do I have electrical cable? Because electrical cable, those, they have a signal, like electrical signal, and they affect the GPS. If they affect the GPS signal, guess what? You have to be away from them, because if they disturb the GPS signal, it means your drone can simply sway away from your site. Okay. Now the other thing that you need to plan is you need to plan for good day, good time. Good day, good time. And what does it mean, guys? Do you remember we talked about the image quality? If you remember, did we talk about image quality? And the 3D model is simply function of the image quality. So if I have good image, like sharp, then a good quality 3D model. If I have hazy, full of shadow, not enough light, do I get a good 3D model? Not really. So which means when you pick one day of your flight / time, not only day, it also has to do with the time, you cannot do your flight late in the afternoon. Why is that? Because late in the afternoon, the sun will be low, you have lots of shadow, and when you have lots of shadow, it means you have a problem with photogrammetry. So that's something we would like to have. We need to have our flight early afternoon, and it has minimum shadow, minimum shadow. Good day, you cannot fly your drone while it's raining, while it's cloudy, because if it's cloudy, then you have not enough light. If it's raining, then it may cause some problem with your sensor or maybe your battery. Okay. Now, once you do that, you need to go through approval list, which means you have to have the license and you also must obtain the owner's approval. Okay. Very important, guys. It doesn't mean that I have a license, like I'm a licensed pilot. I can just go and fly my drone anywhere I like. For example, if you want to fly your drone at SATE and you are okay, have the license, you have the training, everything is okay. Can I just go and fly my drone in a private property? No, you cannot. You must obtain the owner's permission to fly your drone in their area. Okay. Now let's say all this list, like all the checklist is already done. Then this is time to move into the site and to start capturing your data. There's few things you have to do it on site. Number one, you must pick a takeoff point and landing point, and not necessarily to be in your area. So you could be away from your area because your drone will fly up and then navigate itself to the area to be scanned. Well, if you have one good spot in your area, great. Let's say in SATE there is one area where you can fly your drone, then you can fly it from this point. Now, what are the characteristics of good point? Number one, you must have a flat surface. You cannot really land your drone on a slope because simply maybe you break your drone. Okay. Also, it has to be away from power line and away from trees. Why is that? Because those power line and trees, they have a problem with the GPS signal. Remember, the drone is completely controlled by the app. And how the app will know and bring back your drone? Because the drone must have a GPS. I think I discussed this before. Why a surveying drone must have a GPS? Because you can see the drone must go to one specific location where it was required to take an image over there. How can we go to this specific location? Only because we have a GPS. So that's really great. But the problem is, if there is something dangerous for the GPS signal, it will interrupt my GPS signal, like power line or maybe trees. Then I have to be away from those power line and trees when the drone lands or take off. Now, finally, when the drone comes back and you have captured all the required photo with a good geometry, and I will talk about this one probably next class, not any random image can be used in photogrammetry. Remember this is one of the rules. Not some random images can be used in photogrammetry. The photos must be collected in a specific consortium or configuration. They must maintain some certain level of overlap. Okay. Then once we have those photos, we go to the next step, which is data processing, where you can see all the steps. Number one, input the images. Number two, input the ground control point, like the XYZ for the scaling purposes. And simply let the software run and create for you a fantastic full texture 3D model. Any questions so far? Any questions so far? Hello? Any questions so far? Okay, now what I will do, to be honest, I'm going to spend the next 20 minutes or less on a Pix4D capture. So Pix4D capture is an app that you download. Use it on either your cell phone or tablet where you have an Android or OS system. Okay. Here I did something. I found one emulator. I'm not sure if you know about those emulator that turns your, you can run an Android app on your tablet or computer, sorry, on your computer. So right now what you see, I am using those emulators to run an Android app on my laptop, which is not, in general, it doesn't work this way because your laptop has a Windows system, your a cell phone, it has Android, and it doesn't work because it's different operating system. However, using those emulator, I used here something called BlueStacks. And in BlueStacks, if you install it, you should be able to run any app on your cell phone, on your PC, or on your laptop. So what you see here is Bix4D capture. And remember, so far you have here the two names, Bix4D and Bix4D capture. Are those things the same? Bix4D capture and Bix4D. Any thoughts? Bix4D and Bix4D capture. Those are two different things. One is an app that you only use to collect the photos, and the other one is called the Bix4D. That's a software that takes all those photos and process and create for you a 3D model. Okay, so the thing is, Bix4D itself is not free. You have to pay, while Bix4D capture, which is an app, it's free of charge. My objective in the next 15 minutes is to show you a kind of a quick demo on Bix4D, which is really super simple. Now, when you run the software, you can see the first like window that you see is kind of several kind of drones. Like Bix4D is affiliated with the most popular drones. So you can see it's affiliated with the DJI, and you can see Phantom 4 version 2, Phantom 4 Pro, 4, Mavic 2. So all those are different drones of DJI. Also, it contains some other drones like Parrot. So anyway, let's say I'm going to go with with the Phantom 4. This drone, I had it, but I sold this drone, but I had it. So all you have to do is you click here on this drone. So you're telling the software or the app, I am using Phantom 4. Then you say activate. Okay. You know what is asking here to install something, to install it right away. And once you go to the next window, just give me some time here. I will have to install another app. Okay, just gonna take a minute or so. Guys, if you have Android, by the way, if you have Android, that's simply the Google Play, like the Google Store, where you can download all your app. Okay, this is something, as I said, you can need to do it on your cell phone, and you, in general, you cannot do it on your laptop or PC unless you have an emulator that emulates your Windows system into an Android system. So anyway, I'm going to let the software continue downloading, and I'm going to talk about this the page here. So this is your second window when you start your app. So what are those? Very, very simple. Those are different design for different mission. So for example, this mission here where my cursor is, this mission is called grid mission. And you can see the pattern along which the drone will fly. It will go in a kind of a zigzag, like kind of parallel flight line, until it covers the area of interest. Okay, so this is called the grid mission. There is also something called the polygon. So the polygon, it's almost the same. The difference is the area of interest here is kind of rectangular or square, while in this mission here, you can choose any area shape you like. Double grid, it means you go in two perpendicular direction. So you go first on the green flight line. Then once you're done, you go into the gray flight line. Lastly, we have a circular mission, where simply if you choose this mission, your drone will loop around your building. Typically, this is designed for a single building survey, where it simply captures the sides of your building. Are you guys following so far? Are you following? I need confirmation, please.
Yes.
Yeah.
So the next step is you need to pick one of those. It depends on your application. Best, to be honest, for myself, Tahir, I will go with double grid mesh because simply it captures your building from all the sides. So if you have a built-up area that has building, and you want to create really a 3D model, for example, for gaming or something, so this is the good mission. Okay. You know what? For simplicity, I'll just pick this one. So what happens here once you pick the mission? Simply the app will go and show you what. So what you see on my screen is simply kind of Google Map. Okay, Google Map. So I'm not sure if it's gonna work because typically this is run on a cell phone where your cell phone has a GPS, while I'm running right now on Simply or my laptop which has no GPS. So if you have a GPS, GPS will read your location and it will show you here. Will show you skip get started. Okay, so you can see here I can simply turn on my satellite image. I'm pretty sure that this is not really something that you are not aware of. This is something just like when you go from one place to another place using Google. Okay, so you can show a map or you can even show a satellite image. Okay, I'm just having hard time right now because the thing is, as I said, I don't have my I'm not running this on my cell phone. So if you have a cell phone which has a GPS, it knows where are you on the earth, like you are in Calgary or you are in Edmonton or maybe you are in Egypt. So it will simply show you here on the background, simply Google Earth map. Okay, and again, I cannot get this right now, but you guys can imagine what's happening. So all you have to do is simply pick these points. If you see these points, you can see I can stretch my area to cover my area to be scanned. Okay. So you can see the software allows you to add some nodes. So I can click on this plus sign and I can simply grab it this way. You can stretch this area as much as you can until you cover your area. For sure, if you have a Google Earth, for example, you want to survey Sage. So if you have a Google Map on the background, what you will see is you will see all the building, you will see 16th Avenue, you will see 14th Street. So you can precisely set what are the boundaries or what's the boundary of the area of interest. Once you're happy with the area of interest, what happens is here, there are few things you have to do. Number one is you can change the flying height. So on the left side, there is a scroll bar. Right now, my flying height is 50 meters. I can certainly go and change my height. Right now, I can go to 60, I can go to 70, I can go to 100. And a couple of things you need to notice. Now, I'm asking you, should I fly too high or too low? Let's say I don't have a problem with the building. Let's say I don't have a problem with the building. So and I have an area which has no building. I'm asking you, should I fly so high or should I fly so low? Any thoughts?
Somewhere in the middle.
Exactly, that's the right answer, I guess, because simply if you fly too low, what happens is, yes, you will see lots of details, but every single image will cover very little on the ground, which means you end up with so many photos, okay? How about, and by the way, when you need to capture so many photos, it means you need to spend more time in the air. How about the other extreme? When I fly so high, I see less details on the ground, okay, because I'm flying high. But when you fly high, every image covers more area on the ground. It means I need less images and my time in the air will be less. And remember, why I'm concerned about the time in the air? Why is that? Why I should be careful about the time in the air? Why is that?
Battery.
Battery life. Thank you so much. Okay, so I'm gonna do some testing here. I want you guys to see a couple of things. Please see this GSD. I want some confirmation. Do you see this GSD? On the left, GSD, do you see this number?
Yes.
And also you see here on the bottom, the time required to finish your mission. Right now, the time is 4 minutes and the GSD is 2.58 centimeter. Please watch what happens as I go up. Please see what happens. Two things will happen. I'm going up. I want everyone to see what happens to my GSD. Now I'm at 70 meter above ground. What happened to my GSD? I see less details, so my GSD will get bigger. But look at the time. When I go to larger time, I go to higher elevation, the time will go to 3 minutes, 30 seconds. So that's exactly what I said. When you fly high, you see less details. So the GSD, which is ground sampling distance, goes up and the time will go down. How about if I go to the opposite? So I go down, I go from 70, I go down to, let's say, 50 meter above ground. What happened is here, I see more details. So my ground sampling distance gets smaller and my time gets larger. Okay. I'm asking you, what happens here when I'm happy with all those? I like the area. I set the flying height. I'm happy with the time. Really, what you have to do is a couple of things. If you are on site, then you can right away say start. So when you say start, the software will send this mission to the brain of your drone, and simply the drone will have to go along these lines. Do you see these lines? Those white lines, those parallel sweep. Okay, 1, 2, 3. Those are flight lines. And the software will tell the camera or tell the drone, go here, take image here, and then move, and then go here, take one image here. Completely autonomous. You don't have to control anything. Now, what happened here is I'm not on site. I'm not on site right now. What can I do? There is a save button where you can simply save your mission. And then when you are ready on site, you just have to open this mission and start the drones. Very, very clean process. Very, very clean process. Okay. So I think this is what I wanted to say about Pix4D. There are some other things here on the setting, which is you can control the speed. So if you go to the setting, you can control the speed by going very fast or very slow. I'm telling you, which one you think is better will give you sharp image, slow or fast?
Slow.
Yeah, the slow will give you a sharp image and fast will give you kind of blurry image because your drone is fast. And remember, there is a shutter speed, so the shutter will open for a short time and then it closes, and that's how you take an image. So if you fly very fast, then your quality of the image will not be that great. But remember what happened here is that you take a less time. When you fly slower, what happened is, look at the time. Now I need 6 minutes. Okay. Number two, you can control the angle of your camera. It can be completely down, like vertical down, or it can be even horizontal, and you can go in between. You can change your camera angle. Okay. Also, you can control the overlap percentage. This is a big discussion. So just please remember this number because I have a discussion. I'm not sure if it's going to happen today, but we must maintain an overlap between the image. And that's something that we already discussed, okay? That any random images cannot be used in photogrammetry. To use the image in photogrammetry, your photos must overlap. So when they overlap, it means my object will appear in 2 photos at least, and I'm able to create a 3D model, okay? So you can control the amount of overlap by this slide bar here. And you can see when I go to 90, look at how the design changes. Look at the flight lines. So if I go to 90, here is my flight line. If I go to 70, my flight lines will get spread apart. Okay. So anyway, now you know the idea about Pix4D, and probably I will stop recording right now and I will give you a break. But before we break, anyone has any question before we break? Okay, so we'll see you guys after 10 minutes. Time now is 10:56, and I will see you here around 11:07. Thank you.